Example, evaluate the integral of x plus 1 times 2x minus 1 to the power of 1/2 dx. Let's note that this integrand is not a composite function, and multiplying the two terms, x plus 1 and 2x minus 1 to the power of 1/2, is not an option. For this integration, we will still use the method of substitution, but first we solve for x. We begin. We'll let t equal 2x minus 1 and solve for x, as well as construct the substitution. T equals 2x minus 1. We'll solve for x first. Adding 1 to both sides, t plus 1 equals 2x. Now divide by 2 on both sides. T divided by 2 plus 1/2 equals x. We have solved for x. Now we'll get ready to do the substitution. The derivative of t minus 2x minus 1. The derivative of t is dt, and the derivative of 2x minus 1 is 2 dx. In the original problem, we have a dx. The substitution, we have 2 times dx. Divide by 2 on both sides so that we can do a direct substitution. 1/2 dt equals dx. Looking at the original integral, we are now ready to make substitutions and express that entire integrand in terms of t. The integral of x plus 1, we replace the x with t over 2 plus 1/2. So you have t over 2 plus 1/2 in the place of x plus 1, where 2x minus 1 was, that's t, so t to the power of 1/2, and where dx was, in terms of t, the substitution is 1/2 dt. Before integrating, we'll proceed with some algebra. First, we will factor the 1/2 multiplied to the dt out of the integral symbol. 1/2 the integral of t over 2 plus. Add the 1/2 plus 1, that'll be 3/2. Then you still have t to the power of 1/2 dt. Looking at the integrand, t divided by 2 plus 3 divided by 2 has a common factor of 1/2. Let's factor that out as well. This integral becomes 1/2 the integral of 1/2 t plus 3 times t to the power of 1/2 dt. We're going to do 2 algebra steps. We will factor the 1/2 that's to the right of the integral symbol out to the left of the integral symbol. 1/2 times 1/2 is 1/4. And then distribute the t to the 1/2 to each of t and 3. That results in t to the power of 3/2 plus 3 times t to the power of 1/2 dt. We are now ready to use the power rule for integration, but before proceeding, let's provide you with a quick arithmetic refresher. 1 divided by 1 plus 3/2, that's equal to 1 divided by 5/2. That is equal to 2/5. Likewise, 1 divided by 1 plus 1/2, that's equal to 1 divided by 3/2, and that simplifies to 2/3. Now let's integrate. 1/4, open brackets, we get 2/5 applying the power rule for integration times t to the power of 5/2 plus the constant 3 stays put, and the integral of t to the 1/2 applying the power rule for integration gives us 2/3 t to the power of 3/2. Don't forget the plus c. Distribute the 1/4 to the terms in the brackets. 1/4 times 2/5, That's 2/20, which reduces to 1/10 t to the power of 5 halves, plus 3 times 2/3 is 2, and 2 times 1/4 is 1/2 t to the power of 3 halves. Don't forget the plus c. Now we replace or substitute back t in terms of x, so our final integral will be 1/10. Where t was, we put back in 2x minus 1 to the power of 5 halves plus 1/2. Where t was, we substitute back 2x minus 1 to the power of 3 halves plus c.